Hi everyone, and welcome to our last lesson of this unit. Kind of exciting. We're going to be talking about exponents today, so we're going to be kind of switching gears from what we have been talking about. We're going to talk about a kind of exponent that we haven't seen before, called a rational exponent. So our objective today is going to be to simplify expressions involving rational exponents. So what are rational exponents? Well, the exponents that we know how to deal with have also been rational, but they've been integers. So something like x squared or x to the fifth, those exponents are integers. But today we're going to be looking at exponents that are fractions, like x to the 1/2 or a to the 3/4. And we're going to learn what those actually represent and how we can simplify expressions using them. Before we get into what rational exponents really look like, I want us to look at a table of new terminology that we may not have seen before. So I have a table here of different operations, and they're inverses. So operations and the kinds of things that undo them, like multiplication and division, undo each other. And then I want to give an example. So our first thing on this table here is squaring. We all know what something squared looks like. And the thing that undoes something squared is a square root, and that's what we've really been working with this unit. So the square root looks like that. I know we all have seen that symbol plenty of times by now. So just as an example, 5 squared we know is 25. So to undo that, I would take the square root of 25. This is really the square root of 5 squared. Square root of 5 squared, that would give me back 5. So I undo what I originally did to get my number back. All right, what about cubing? So cubing is when I put something to the third power. And how do I undo that? I take what's called the cube root, which looks a lot like the square root, but it has a little 3 there to tell me it's actually a cube root. So that's what a cube root looks like. And let's see an example. So an example would be like 2 cubed equals 8. 2 times 2 times 2. And to undo this, we would take the cube root of 8, which would be the cube root with the little 3 of 8. That's really the cube root of 2 cubed, which would undo that cube and give me back 2. Similarly, I can have something raised to the 4th power, so like x to the 4th, and I can undo that with what's called a 4th root. We don't have a name like cube from cube onwards. We just call it the 4th root. So the 4th root looks very similar, but it has a 4 there instead of a 3. So if I have something like 3 to the 4th, 3 to the 4th equals 81. I'll trust that you can 3 to the 4th equals 81. I'll let you verify that on your calculator. And this we can undo by using the 4th root. So if I take the 4th root of 81, this is really the 4th root of 3 to the 4th, which it gives me back 3. All right, one last one. If I raise something to the 5th power, we call that the 5th root, and it looks very similar, but it's going to be a root with a 5. And let's do an example of this. So if I have 2 to the 5th, this is going to give me 32, and to undo this, I would take the 5th root of 32. So little 5 root of 32, and this is really the 5th root of 2 to the 5th, which gives me back 2. All right, let's move on to some real exponents now. So we just saw that the square root undoes a square. Likewise, a square undoes a square root. So if I have something like this, the square root of a squared, I get a back. That square undoes my square root. I am going to make a conjecture here. I'm going to tell you something new, and I'm going to prove to you why it's true. So a to the 1/2, so 1/2 is an exponent, is equal to the square root of a. And let me show you why that's true. So if I have a to the 1/2, and I square it, well, if we go back to our time when we always said, when in doubt, write it out, this would look like a to the 1/2 times a to the 1/2. And if I have a to the 1/2 times a to the 1/2, this gives me a to the 2/2. I add my exponents there. So a to the 2 over 2 gives me a. So a to the 1/2 squared equals a. But we also know that the square root of a squared gives us a back. So if I have the same thing squared in both cases, and in both cases it gives me a, those two things have to be equal to each other. So a to the 1/2 must equal the square root of a. That's some new terminology that I don't think we've seen before, and it is going to be so important for this section. All right, let's move on to something a little bit more advanced. Okay, so we know, taking a step back, we know that x to the 5th squared equals x to the 10th. If we write it out, we see x multiplied 5 times twice, which gives us x multiplied together 10 times, x to the 10th. So if I have x to the 3/2, where 3/2 is my exponent, this I can rewrite as x to the 1/2 to the 3rd. I really have 1/2 3 times, which is 3/2. So this I can rewrite, now that I know that x to the 1/2 is the square root of x, I can say x to the 1/2 cubed is the square root of x cubed. Another way that I can write this is the square root of x cubed. I can bring that exponent inside my square root. All right, so here's a general rule. If I have the nth root of a all to the m power, I can rewrite that m to be inside my nth root, whatever n is. This could be the cube root, the 4th root, the 10th root. And I can rewrite this as a, I'm going to use my colors here, a to the m over n. M over n. And the tricky part here is remembering which exponent goes where. So whether the denominator or the numerator goes inside or outside. And you can just remember that m goes on the inside, n goes on the outside. All right, let's do some examples with these. I know that was a lot of information thrown at you. I promise you'll get the hang of it. Here's problem number 1, the square root of 36. I know you all know that this one is 6, but I want to tell you a new way to think about these. So I want you to think about it like, all right, the square root of 36 is really the 2 root of 36, right? So what to the 2 power, or what squared, equals 36? So how can I undo this? Well, we know that 6 squared equals 36. So this equals 6. Let's do one with a little bit more difficulty. Okay, number 2 is the cube root of 64 equals what? Well, I want us to think about this. Like, what is it that when cubed gives us 64? So what cubed equals 64? This might take a little bit of practice. I'm sure you won't recognize this at first, but if we do 4 times 4 times 4, that's 4 cubed, this equals 64. So this can sometimes take a little bit of guesswork or some work on your calculator. That's okay. These things will come to be a little bit more natural with time. So it's going to be 4 cubed that's equal to 64. So the cube root of 64 equals 4. Here we have the 4th root of 1. So what is it that when I put to the 4th power gives me back 1? Well, this one is just going to be 1. 1 to the any power is going to give us 1. So 1 to the 4th equals 1. So the 4th root of 1 is just going to be 1. All right, let's do something a little bit different, and let's go backwards, using our exponents to give us something like this. Okay, so we're going the other way now. In number 4, we have 125 to the 1 over 3, to the 1/3 power. So I'm going to put this little guy down here. I want you to remember that a to the m over n is really the nth root of a to the m. Now, if it helps you, I would use color. Use as much color as you need, and I'm going to rewrite this guy in color. So I'm going to rewrite this as 125, and then I'm going to use the same colors I used down here so that we can differentiate between m and n. So m is going to be 1 for us, and n is going to be 3. So this is 1 over 3. And then I'm going to write this in this form. So this is going to equal, so many colors here, this is going to equal the nth root, so n for us is 3, so this is going to be the cube root of 125 to the 1. So 125 to the 1. And now, 125 to the 1 is really just 125. And the cube root of 125 is 5. Because if I have 5 times 5, so if I have 5 times 5, that's 125, because if I have 5 times 5, that equals 25, times another 5 gives me 125. So the cube root of 125 equals 5. All right, let's do one with something other than 1 as our numerator and our exponent. All right, our last problem, 25 to the 3 halves power. So this I took the liberty of rewriting in my colors. I so recommend that you do this also. So I rewrote this in my colors so I know which one is m and n, and I'm going to rewrite it in a root form. So this equals the 2 root. So we know the 2 root is just the square root. So we can put the 2 there, or we don't have to. The one without any number there, we just assume to be the square root, the one that we're normally dealing with. Then I'm going to rewrite, let's see, 25 in there to the 3rd power. That's my m. So to the 3rd power. And 25 to the 3rd power is going to be 15,625. So I'm going to rewrite that. 15,625. Now, we can use our calculators to figure out what the square root of this is. And the square root is going to be 125. So 25 to the 3 halves power equals 125. All right. Thanks for watching. I hope you tried those problems at the bottom of your guided notes. Even if you're struggling, give it your best shot and use these notes to help you. If you have trouble, we'll talk about it tomorrow. Thanks again.